We're standing at the edge of a new technological revolution. But instead of faster computers, it's a whole new kind of computing altogether. Right now, tech giants like Google, IBM, and Microsoft are pouring billions into a technology most people still don't understand: quantum computing. But what exactly is quantum computing? Quantum computing is based on the principles of quantum mechanics. Quantum mechanics comes from the study of quantum physics, and is the study of the fundamental behavior of matter and energy, particularly that of subatomic particles. A quantum computer could, theoretically, solve problems way faster than a traditional computer could. But how does this theoretically revolutionary field of technology work? With classical computing, information is encoded in bits, and each bit consists of a binary digit, either 1 or 0. Modern computer chips simulate bits with billions of tiny electronic switches called transistors, and a transistor can either switch between 1 and 0 or on and off. However, unlike classical computing, quantum computing uses the quantum bit, also known as the qubit, for its basic unit of information. A qubit can take on the value of 1 and 0, but also as a superposition of both values, meaning that a qubit can be 1 and 0 and simultaneously both and neither. Qubits help quantum computing take advantage of superposition and quantum entanglement in order to compute in fundamentally new ways. However, it is important to keep in mind that quantum computing is still a largely theoretical field. While there are many proofs of concepts resembling quantum computers, there is no actual practical quantum computer available yet. But how did this idea of quantum computers become something that may actually be possible? The foundation for quantum computing started in the 1980s. In 1981, physicist Richard Feynman started the idea of quantum computing. He came up with the idea that a computer could use an electron, photon, or other particle to store not just a single 1 or 0, but a number of values simultaneously. This is the basis of the idea for the qubit. A few years later, in 1985, David Duesch at Oxford University fleshed out Feynman's ideas. Duesch created a conceptual design for a quantum computer, including an algorithm to be run on it. This algorithm was very important to the history of quantum computing and laid the foundation for future quantum computing algorithms to be made. In the 90s, Peter Shor outlined his own quantum algorithm. This algorithm could be used to find prime factors of numbers and could do so faster than any classical algorithm. If this algorithm was ever run on a suitable quantum computer, it would theoretically be able to break a method of encryption called RSA. Since then, a plethora of proof-of-concept quantum computers have been researched and designed. In 1998, researchers from Oxford University used a device called the NMR machine, also known as a nuclear magnetic resonance machine, in order to build a 2-qubit computer. This 2-qubit computer was successful in running the quantum algorithm developed by Duesch faster than any classical computer. Sometime later, a group of researchers from IBM created another 2-qubit computer also using an NMR machine. This 2-qubit computer was able to perform a quantum program developed by the mathematician Love K. Grover. Many more proof-of-concept designs have been developed since the 90s. In 2001, a 7-qubit quantum computer was used to factor the number 15. In 2009, Yale researchers created a quantum processor consisting of 1 billion aluminum atoms. Many more have been built since then, but what modern advancements have we seen in the field of quantum computing? Quantum computing has made some serious progress throughout the years, but it is time to see what current advancements are being made and what issues researchers are currently facing. On December 9, 2024, Google revealed its latest quantum computing breakthrough in the form of a quantum computer run on a new computer chip called Willow. This new quantum computer, Google claims, apparently needed less than 5 minutes to perform a mathematical calculation that one of the world's most powerful supercomputers would not be able to complete in 10 septillion years. That is a length of time that exceeds the age of the known universe. This new computer is apparently able to do this by using a new form of error correction. This means that quantum computers might be on the path to overcoming their own mistakes and performing calculations that could advance many fields of research. This could accelerate the process of drug discovery and break the encryption that protects computers vital to national security. We've discussed all of these advancements in quantum computing over the years, but why are major leaps in quantum computing so minimal? In the past, there have been issues with making qubits reliable and resistant to noise. Qubits are very delicate, and so stable qubits are needed in order to build an actual quantum computer. However, stable qubits tend to be big, and therefore difficult to fit into a practical system. Stable qubits also tend to be slow, which is undesirable as they would not be beneficial to the high-speed dream that is quantum computing. New materials that have the right properties would need to be developed in order for quantum computing to become a reality, and this is the major issue that has plagued researchers. However, very recently, on February 19th, researchers at Microsoft unveiled their latest quantum computing breakthrough. Microsoft claims to have created a new state of matter. Their claim is to have created the world's first topoconductor, which enables them to create topological superconductivity. This is a state of matter that only previously existed in theory. But why is this important? Well, Microsoft claims that since last year, their researchers have been looking into the Majorana particle. The Majorana particle is a quasi-particle within the topological state. Microsoft claims to have harnessed this particle by designing a chip that is able to detect the presence of the Majorana, allowing them to create a topological qubit. Apparently, this topological qubit is said to be small, reliable, and controllable, which solves the noise problem that caused errors in qubits as previously mentioned. These topological qubits also apparently allow them to build entirely new quantum architecture, and can apparently scale to 1,000,000 of these topological qubits in a tiny chip. However, there is much discourse about whether these findings from these large corporations are true or not. There is a large concern over the lack of solid evidence or research. Google has been proven wrong in the past about their quantum research, and a lot of its quantum computing research is met with skepticism. Microsoft is also under fire for a lack of detailed, peer-reviewed research papers. There's also claims from distant experts and scientists about the absence of tests Microsoft should have used in order to look for the Majorana particle. However, it is important to note that since these findings are from large businesses, they also have to look out for their own interests, meaning that spilling their secrets and showing all their research and progress would not be great for their businesses. Nevertheless, the secrecy is the exact reason why people are so skeptical about these so-called breakthroughs. And so, even though there are many challenges with the development of quantum computing, the progress we've made so far is incredible. So what does the future of quantum computing look like? The future of quantum computing isn't just about faster computers. It's about transforming entire industries and reshaping our way of life. The future impacts of quantum computing are limitless, and quantum computing could transform industries. From designing new drugs to optimizing global economics, quantum computing could impact almost every field. Encryption and national security will have to change completely in order to keep up with quantum computing. Quantum computers theoretically would be able to break almost all levels of encryption thanks to the algorithm designed by Peter Shor. The field of medicine and drug discovery will be rapidly boosted with the assistance of quantum computing. Quantum algorithms would be able to solve complex optimization problems necessary for drug discovery, would also be able to simulate highly accurate molecular systems, meaning that scientists might be able to develop personalized medicine tailored specifically to an individual's genetic makeup. Quantum computing would also be able to solve many long or unsolved mathematical problems very easily. It would even be able to solve many theoretical problems that have been posed by mathematicians throughout history. Quantum computing will be able to bring machine learning and AI to the next level as well. Quantum computing would allow algorithms to process and learn from data in ways that are way beyond what current computers can handle. The field of economics would also massively benefit from quantum computing. Quantum computers would be able to model many different outcomes from the financial market. It would also be able to detect fraud more effectively through the use of learning algorithms. Global economics would also shift, as quantum computers would be able to better optimize and manage trade and supply chains. Overall, quantum computers would affect everyday aspects of life. It would be able to automate many jobs, way more than current advancements in AI and machine learning would. It would also make cheating in school even easier than with current AI. However, it might also make it easier to detect cheating as well. Quantum computers would be able to change the way we interact with cybersecurity and privacy over the internet. And most importantly, quantum computing has the power to change global politics and national and international relations. The thing is, it depends on who gets access to the power that is quantum computing first. So to conclude, quantum computing is not just the next upgrade in computer technology. It is a completely new way of processing information, solving problems, and much more. We've gone from the theoretical physics in the 1980s to real machines that can perform calculations we once thought were impossible. And even though we're still in the early stages, the pace of progress is accelerating quickly. Right now, researchers are solving problems that classical computers struggle with, and in the future, they might solve problems we haven't even thought of yet. Of course, there are challenges and risks with handling this technology, but if we keep pushing forward, we might just be on the verge of breakthroughs in medicine, AI, security, or even how we understand the universe. This technology has the power to reshape our world. Quantum computing is a massive leap forward from the computers we use today, and while we're just beginning to unlock its true power, the possibilities are endless.